So we are saying that acidic oxides react or dissolve in water to produce or to form acids. For example, sulfur trioxide reacts with water to form sulfuric acid. Okay, sulfuric acid. Sulfur dioxide, the difference is there, reacts with water to form sulfurous acid. Sulfurous acid. Note the difference. Sulfur trioxide plus water, sulfuric acid. Sulfur dioxide plus water, sulfurous acid. Good. Then carbon dioxide plus water we form carbonic acid. Carbonic acid. Phosphorus pentaoxide plus water you form phosphoric acid. Phosphoric acid. Okay? So you note that when they dissolve in water, the acidic oxides will always produce acids. Okay? That is also very important. Those are simple tricks of passing chemistry. Okay? Then, acidic oxides react with alkalis or bases to form a salt and water. This is extremely important for your chemistry. That acidic oxide plus a base or an alkali, you must produce a salt and water. So your only task is to know which salt will I form, depending on the base that you are using. For example, carbon dioxide is an acidic oxide, reacts with sodium hydroxide, which is a base, right, to form sodium carbonate and water. So the sodium carbonate is the salt and then water. How has this salt been formed? Just combination of this carbon dioxide plus the base. You can see that this metal is the one which is in the base there. Sodium hydroxide forms sodium carbonate when reacted with carbon dioxide. And the other product is water. Let's look at another example. Sulfur trioxide plus calcium hydroxide, which is the base, we form calcium sulphate. Calcium sulphate. I want you to note again that the salt has been formed from the metal which is in the base. So the calcium is the one that has combined with the sulfate ion. Okay? So this reaction in detailed chemistry, you realize that actually first proceeds through formation of the acid. Remember that these acidic oxides dissolve in water to form acids. So what does this one form? This one forms carbonic acid. Carbon dioxide forms carbonic acid. Then that carbonic acid will now react with the base, which is sodium hydroxide, to form sodium carbonate and water. That is something that is a trick which you should know. What does this one form? Sulfur trioxide forms sulfurous acid. Then this sulfuric acid, not sulfurous acid. Then the sulfuric acid now reacts with the calcium hydroxide to form calcium sulphate plus water. But that is just a trick. Okay? But this is very important to note. Acidic oxides plus alkalis, you form a salt and water. Basic oxides plus acids, you form a salt and water. Very simple thing to master. Okay, and again, please note that acidic oxides do not react with acids. They are of the same category. Acidic and acid, they are of the same category. They cannot react, please. Good. Then, further example, sulfur trioxide, of course, dissolves to form sulfuric acid. Sulfur dioxide forms sulfurous acid. Carbon dioxide forms carbonic acid. Phosphorus pentaoxide forms phosphoric acid. Then we have the other group of non-metal oxides, which are called neutral oxides. We say these ones are neither acidic nor basic. They are completely different from acidic oxides and basic oxides. So what are they? They are metal oxides, which are usually insoluble. Rather, they are non-metal oxides, which are usually insoluble in water. What are they? Non-metal oxides, which are insoluble in water. They neither react with acids nor bases. They cannot react with acids, meaning that they are not bases. They can also not react with bases, meaning that they are not acids. Okay? Very good. Now, they also have no effect on litmus paper, meaning that even if you dip to blue litmus paper, the color of the litmus paper remains blue. If you dip to red, it will remain red. They have no effect. What are they? We have water, which is an oxide of hydrogen, and the formula is there. We have carbon monoxide, which is an oxide of carbon. It is there. And then we have nitric oxide, which is nitrogen monoxide, and the formula is also there. Good. Then we have, lastly, we have amphoteric oxides. Amphoteric oxides are metal oxides which behave like acids and also like bases. They show both acidic properties and basic properties. So they are like both metal, they are both acidic oxides and and basic oxides. Okay? So that means that they can react with acids, showing that they are bases to form salt and water. They can react with bases to form salt and water, showing that they are acids. Okay? An example is zinc oxide. Zinc oxide is an amphoteric oxide. It reacts with sodium hydroxide to form a salt which is called sodium zincate. Sodium zincate. It has this formula. You don't need to cram that formula. And water. Then it can also react with acids. For example, hydrochloric acid plus zinc oxide will form zinc chloride and water, showing that they are actually bases. When they react with acids, they show that they are bases. When they react with bases, they show that they are acids. Another example is aluminum oxide. It reacts as a base by reacting with, for example, aluminum oxide reacting with hydrochloric acid to form aluminum chloride plus water. That shows that it is a base. Aluminum oxide again can react with acids. Can react with bases. For example, aluminum oxide plus sodium hydroxide solution will form sodium aluminate, which is a salt, plus water. That shows that it is an acid because it is able to react with a base. Good. Now, this is just a summary of the examples. You can look through this list. You realize that these are all non-metal oxides, and these are metal oxides. These are also metal oxides, but they are amphoteric, meaning that they are both acidic and basic. Then these are neutral oxides. Then we have a summary here of the properties. That basic oxides react with acids, okay, to form a salt and water. They dissolve in water to form alkaline solutions. Amphoteric oxides, on the other hand, react with acids to form a salt and water. they also react with bases or alkalis to form a salt and water.